Hello, we're from ChemPraxis and today we'll be covering Paper 3, Variant 2, May-June 2024. So the students are told to plan and carry out an experiment to determine the enthalpy change when 1 mole of anhydrous sodium thiosulfate is hydrated. So one student suggested adding 5 moles of water to 1 mole of anhydrous sodium thiosulfate and measuring the temperature change. That would not work. So the teacher suggested that we should determine the enthalpy change when 1 mole of hydrated sodium thiosulfate is dissolved in water. And this is the equation. So explain why the student's suggestion to adding 5 moles of water to 1 mole of anhydrous sodium thiosulfate would not be a suitable method to determine the enthalpy change. So first of all, you cannot accurately measure change in temperature for solid. And also, some of them would dissolve instead of forming the desired hydrated sodium thiosulfate. And of course, not all would form pentahydrate. So now we will proceed to doing the teacher's method. First, support the cup in a 250 cm3 beaker. Then, use the 25 cm3 measuring cylinder to transfer 25 cm3 of distilled water into the cup. Then, place the thermometer in the water and tilt the cup. Next, weigh the container with FB1 and record the mass. Now, we will add all the FB1 to the water in the cup. Make sure to stir the mixture and measure and record the minimum temperature reached. Re-weigh the container and any residue of FB1. Record the mass. This is the table that I have recorded, and these are all the values that I have recorded. And make sure to always write this /G and /Celsius, and make sure that whenever you're recording the mass, it has to be consistently 2 or 3 dB. And for the temperature, you need to make sure that you're using 0.0 Celsius or 0.5 Celsius. All of these are written at the above. Now that we have gotten the value, now let's move on to the calculations. So for the first question, calculate the energy change in joules when FB1 is added to water. So for the energy change, we'll be using the formula Q equals to MC delta T. The mass will be the distilled water, and then you will get the value 627 joules. Then next, calculate the enthalpy change in kilojoule per mole when 1 mole of hydrated sodium thiosulfate, Fe1, dissolves in water. So first we have to calculate the amount of thiosulfate. We will use the mass and the MR, actually this is MR, to get the mole. So once you get the mole, you are able to calculate the enthalpy change already. So you just add in the energy change and make sure to convert it to kilojoule, and you get the value 31.35. And the sign has to be positive because this is an endothermic reaction. Now let's move on to the next question. The enthalpy change when 1 mole of anhydrous sodium thiosulfate is dissolved in water is negative 8.1 kilojoule per mole. And this is the equation. So now we have to use the Hess law, the Hess cycle, to find the answer, right? So we already have the first equation over here. So now we need to find out what is the answer in the end. So it has to be from this direction to this direction. So we just add negative 8.1, but because the arrow is moving this side and we need the reaction to move this side, so it would be negative 31.35, and then you get the answer negative 39.45, and yeah, make sure it's 3 to 4 significant figure. And yeah, so for the final question, a sample of FB1 was contaminated with anhydrous sodium thiosulfate. State what effect this would have on the temperature change in B. Explain your answer. So the answer is the temperature change is decreased. And why is it decreased? Because reaction of anhydrous sodium thiosulfate is exothermic. And because it's exothermic, it increases the temperature. So when it increases the temperature change is decreased. So yeah, that's for part 1. Now, for question 2, iodate ions contain iodine and oxygen. They have the formula of this, where X is an integer. In this experiment, you will determine the value of X in an iodate. You will first react this with an excess of iodide ions to form iodine. The amount of iodine produced is then determined by titration with thiosulfate ions. We will now proceed with the experiment. First, fill the burette with FB2. Next, pipette 25 cm³ of FB3 into a conical flask. Use the 25 cm³ measuring cylinder to add 10 cm³ of FB4 to the conical flask. Use the same measuring cylinder to add 10 cm³ of FB5 to the conical flask. Add FB2 from the burette until the solution turns yellow. The initial burette reading is 0 cm³. Next, add 10 to 15 drops of FP6 to the solution in the conical flask. Continue to add more FP to form the burette until the blue-black color just disappears. My final burette reading is 33.7 cm cube. Make sure to repeat the experiment 1 or 2 times and get concordant values. So my rough theta is 33.70. Make sure that it is in 2 decimal places. And below here, I've created a table. So for titration questions, my method of completing it is, first of all, the question mentioned that it has to be, the end product has to be yellow. So you will expect your titration to reach yellow and that's the end point. However, what I would do is, I will titrate my rough trial as fast as possible to quickly, immediately get yellow. And let's just say I rushed my titration for my rough titration and I got 40 cm cube and I got yellow. But that is definitely exceeding the correct answer, but it's fine. You put your rough titer as 40 cm cube, and for the first trial, instead of rushing fully, you rush until 30 cm cube. Then you start to slowly titrate, drop by drop. And you do it very accurately and get the final value. For example, your accurate value is 33.70. So if you're very confident and you already know that that is the accurate value, you got that as your correct answer. So for the second and third trial, you don't have to do it again. Just write the correct value. Then you can save a lot of time. So for the mean value, because I already know that 33.70 is the correct answer, so I just copy it down and divide by 3 and yeah, I get the answer later. Make sure that it is in 2 dp and you must show your working. Okay, let's do the calculations. So for calculations, make sure that it is in 3 or 4 significant figure. So the next question, they want you to find the amount of iodine. So this equation is from here. So you already know that this is Fp2. So first find the amount of mole of Fp2. So at the back, at the front here, you can find it's a 0.1 concentration. So you just use the formula N equals to CV over 1000. So the concentration is 0.1 volume. So at the volume at the top here, you already know that you use 33.7. So just plug in the value. Then you get the answer 33.7, 3.37 times 10 to the power negative 3. So you can see the ratio, it's 1 to 2. So you know that the iodine is, you have to divide by 2, then you can find the answer that is 1.685 times 10 to the power of negative 3. And now you want to calculate the amount of mole of this ion in 25 centimeter cube of Fp3. So at the front, you can see that Fp3 has a concentration of 0.0140. So again, just plug in the value into the formula, then you get the answer 3.5% to the power of negative 4. So for the question 4, they want you to find the value of X, and they gave you a hint. Use the ratio of your answers to CI to CII. So after you use the ratio, you find out that it's 5. So that means that for one of this, you need to have 5 iodine. So if you look down here, if iodine is 1, just 1 only, this is the equation. And when you look at the equation, you realize something. The charges here are balanced out, meaning 0 charge. Total charge is 0. So with this ratio, you know that for one of this ion, you have 5 iodine. So just put in 5 iodine, then of course there's 10, so you just add it like that. So what about the water, the H plus ions, and the X? So just balance the charges out. Balance, balance, balance. Make it into 0 charge in the end, neutral. Then you get the answer that X equals to 5. So for question D, a student carries out the same experiment as in A, but uses the same concentration. However, the ions used is different now. Earlier on, we have IO5. The X value was 5. But now the X value is 2. So what will happen to the volume of Fp2? So you see, IO2 minus, there's 2 oxygen here. That means you need to have 2 moles of water. There's 4 hydrogens, 4 H plus. You want to neutralize the charge, 3 iodide. There's 4 iodines, so 2 moles of iodine. And you realize that there's only 2 moles of iodine instead of 5 moles. It's different now. So since there's only 2 moles of iodine, you need lesser Fp2. Because in the equation, if iodine decreases, this will also decrease. Because there's little iodine now, so you only need little sodium thiosulfate. That means Fp2 will decrease. So the answer will be, volume of Fp2 will be smaller. Why? Less iodine produced due to lesser change in oxidation state. You don't write the square bracket, you can just write the balance equation. And you can secure your 2 marks. Next, we will be doing qualitative analysis. So Fp7 is an aqueous solution of a salt containing 1 cation and 1 anion, both of which are listed in the qualitative analysis notes, which means that the cation and anion both are in this table. So for test 1, add aqueous barium chloride or aqueous barium nitrate. This is to test for the presence of sulfate ions. Then for test number 2, we are doing all this to test for the presence of nitrate ion. Then for test 3, we add aqueous ammonia to test for which cation is present in this table. First, we will add in Fp7. Next, we will test FP7 with barium chloride, and as you can see, no reaction. Now, we will be testing FP7 with sodium hydroxide. When I add a little sodium hydroxide, white PPT forms. Now I will be adding sodium hydroxide in excess. The white PPT has turned soluble. The mixture from earlier will now be heated. And as you can see, the red litmus paper stays red. We will then continue with adding aluminum foil into the mixture and start heating it. Fizzing has now occurred. And as you can see, the red litmus paper has turned blue. Now we will be testing FP7 with ammonia. By adding ammonia dropwise, we can see that white PPT has formed. Now I will begin adding ammonia in excess. As you can see, the white PPT has turned soluble. So after doing all the 3 tests, we now know that for test number 1, there was no visible change. So we know that there's no sulfate ion in FP7. So for test number 2, when we add aqueous sodium hydroxide, when we first add a bit of it, we can see there's white PPT. And when we put it in excess, then it becomes soluble. And after that, we warm it gently, but the litmus stays red. But when we add aluminum foil, it starts to fizz, and later on the gas turns the damn red litmus paper to blue. So then we know that nitrate ion exists, nitrate or nitrite ion exists. Then for test 3, when we add aqueous ammonia, there was white PPT and then soluble in excess in the end. So because of that, we know that the cation would be zinc and anion would be nitrate or nitrite. So for the next question, we need to identify whether the anion is a nitrate or a nitrite. So the test would be adding a few drops of acidified aqueous KMnO4. Potassium permanganate will now be added to FP7. And as you can see, it did not turn colorless. After adding a few drops of acidified aqueous KMnO4, we found out that the solution stays pink and did not turn colorless. So then we know that the anion is a nitrate, which is NO3-, and not a nitrite, which is NO2-. So for the next question, we need to identify the anion of FP8 and FP9. And one of the anions contain oxygen but not nitrogen. So from here we can identify that if there's no nitrogen in the anion, that means the only anion that has oxygen would be CO3 2-, and the other ion is a halide. So if you want to test for the presence of carbonate ion, we definitely need acid, because then we can test for the presence of carbon dioxide, which will turn the lime water milky. Then for halide, we can use AgNO3, because then a PPT will be formed and we can further test it with NH3. to see if it's soluble or not soluble. This is lime water. We will now begin testing for FB9. We will now add HCl into FB9. Make sure to close the tube so that no gas will be escaped. We will now test whether or not the lime water will turn milky. The lime water has now turned milky. We will now begin testing for FB8. Silver nitrate is added into FB8, and pale yellow PPT has formed. Ammonia will now then be added into the mixture, and the pale yellow PPT is insoluble in ammonia. So after those two tests, we found out that when we add HCl aqueous into FB9, we found out that at first it was fizzing, and later on the carbon dioxide will turn the lime water to white PPT. So we know that FB9 has carbonate ion. So for FB8, we tested it with AgNO3 and it gave us pale yellow PPT. So it has iodide. But we need to confirm whether it really is iodide. We added ammonia and it was insoluble in aqueous ammonia. So then we know that FB8 has iodide and FB9 has carbonate ion. So we need to write ionic equation for one of the anions tested. So you can either write an ionic equation for AgI or for carbonate ion.